Hey everybody, just checking on recording, make sure the music's good, hope everyone's well. Thanks for joining me. I'm trying to find better ways of making presentations in the comfort, and here I'm going through, this is my globe at home, and this is my Mercator map at home. So I decided to draw the Mercator map, and I've got 40,000 kilometer equator, 20,000 kilometer height, and what I'm trying to do here is make an accurate map of the world. The area that we have is 511 million kilometers squared. I use kilometers because that's the most applicable thing to geometry. The base, the origin of geometry. Sorry. Anyway, so draw. I'm gonna turn this music off. Actually, it's quite distracting. Yeah. So we have my measurements. The globe that I've compared this to has got 56.6 centimeters, and then naturally, that's the equator, and the height would be 28.3 centimeters. So that was applicable to the measurements of the globe that I used. So they're comparable. You've got 28.3 centimeters for the globe and 56.6 centimeters for the globe. So a comparable experiment. So marked it down into 24-hour zones. 40,000 divided by 24 is 1,666 kilometers per time zone, and the height would naturally be split into 12 if you want to make it properly equidistant. So that would be my next step. So what I did was, I'm trying to get some pictures. Maybe I've got this in the wrong order. Clearly do. Yeah, so what I did was I broke up into 24 zones at the equator, and then the markings in the north and the markings in the south, where the triangles from the equator point down to the exterior, those there were half spaced. So if I went like 2 centimeters per time zone, I went in 1 centimeter at the poles and then lined them up that way. And I think they naturally created natural straight lines to go from one triangle in the south to one triangle in the north, and to get that separation. So as you can see on the left there, I've cut out the excess, trying to see how that wraps around my globe. So that was my experiment. So I wrapped around like that, but I only compared a few of them just to see what the results would be, instead of spending another 10 minutes cutting out the rest of it, seeing what adjustments needed doing. Naturally, using basic maths, half base, which is 1,666, which is where the 24 is, that one width of a time zone at the equator would be 1,666 kilometers, so it would be half of that times the height. We already know the height would be 10,000 kilometers, because we know that's 10,000 kilometers from the equator to the either pole. So basic formulas, if you're struggling with formulas, just go on the internet and just type in the words, how do you work out the area of something. An area, yes, the Mercator map is flat, so you're trying to make something that is usable in navigation. The Mercator map is not usable in navigation. without the computer or simulation speeding up the movements of the airplane or anything traveling in that area. So I tried it on there. Yeah, went straight to the pole, all sorted. Done it again there. Also, half of that would be 4.16 million kilometers. So half a triangle would be that area there, and then a fourth of that triangle, which is that triangle that I've marked at the bottom, just a line across, that whole area there would be 2, and I've got 4 of those to make up, because you would take that bottom one, place into the top, and then you'd still probably the angle on this is wrong, or maybe it's right, but if I trimmed out enough of it, then naturally the bottom triangle would fit into the top of the triangle 3 times. And then when you look at the flat earth map, and which is impossible, but like the inner triangle would be 1/4 of the total triangles, because the outer triangles, there'll be 3 of those on the exterior past the equator. Like I always say in my videos, the magnetic equator is more logical to be the Earth's equator. We've chosen the movement of celestial, which moves in a way that we probably haven't recorded it properly in the last 500 years. So we don't know what happened before, therefore that we can't, move forward. So as I've tried to say on my last video, where you probably need to go to something like 40 degrees north, then you start getting gaps. So here I've taken off too much. Anyways, but this there's the whole thing there. Ask questions, I'm happy to answer. I'm a lovely guy. So bit of blue tack pulled over there, had the spacings of the triangles. So how am I going to find a measurable area of something that everybody agrees would be close enough, or if not accurate? So that didn't work. So as I was saying about the triangles, the top triangle fits into the bottom 3 times, and above there we have 1. There'll be 1 unit, and then next to it you can split into 2 half units. So if I took one of those half units, and you see on the left hand side I've coloured in 2 triangles which will be close to the area of those 2 halves. So those 2 areas there would be a half and a half, so make an extra 1. Going back, if you've got 8.33 million kilometers squared, and you've got 24 zones of that in each hemisphere, then you'd have 48 of those triangles. Do the maths, and you get 400 million kilometers squared. And then by adding these 2 halves at each, in this experiment I've added on to one side, but it needs to be equal, so that when I start plotting coordinates onto it, then we'll be able to see what a real map of the world that's usable in navigation without exaggeration, equidistance, etc. What you have to remember is that the numbers they give you: 40,000 kilometer equator, circumference left, right and center, yeah, in any direction. So there's a number, okay? We've got a number. You get 360 degrees and you divide that by 40,000 kilometers, you get 0.009 degree drop, up, whatever. I don't know what it is. This is why I'm doing this. I'm going to change my name to Prolate Earth, and that would, therefore, I don't fit into any stereotypical category, because it's a category on its own. Prolate is something that I, by mistake, learning how to make flat Earth maps. My very, 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 very first understanding of how you learn to make maps by teaching myself because it's basic geometry, anybody can do it. And from there, my first result was prolate, and that's because the sphere uses lines of parallel. They do not use degrees. In spherometry, the compression happens after about 35-40 degrees. So those two there. So if you add those two to the equation, you have 400 million kilometers squared. Those are 1 million kilometers squared. Or was it 2? I have to remember what. Bear with me. That's 2. That's equal to 2. And then 2 of those times 48, we get 96, but you round off, you get to about 500, and with adding on the 40,075 equator and the 40,008 polar kilometers, yeah, you're going to get to about 511. So this is the bit I cut out, because I put some paper behind everything again, because I knew that the example I've done there was my first attempt at having those two triangles like I talked about. Trying different things out with this, because you can always make stuff look good and then photocopy. So many ways to do stuff. My famous children's atlas, great for nice and cushioned for using compasses and geometry. This here I wrote 400 million kilometers squared. I'm trying to remember where I got the extra 24 kilometers squared. Ignore that. I think that was a mistake. Yeah, these are just pictures. Yeah, I wrote these things, but then I got the whole thing wrong. But still there is missing, but the acceptable error, acceptable error is 5%. No, it should be like 1%. Just trying to remember where I got this 24 from. It might come back to me, but I think anyway. So these are the cutouts. I've done the whole jobby there. But like I said, to get that extra to be equal, it's better to put that extra and split it between both sides, and therefore the equator, as I've tried to prove, when you look down at the northern hemisphere or look down the southern hemisphere from above the pole, then the diameter of the sphere as far north as, I was saying, 30 maybe 40 degrees is still going to be roughly the same diameter as the equator. So this, we're at there, so it fits over. I thought a lot of my models do end up coming out looking like crowns or headwear of Egyptians and stuff. Headwear is the symbolization of what a person believes or supports. All headwear. Look at every single hat that's ever been made. That was made from a style and the origin being that's what the people believed. You've got the Chinese. They've got or the typical hat that is cone shaped. So, and then you got, look at hats. Look into hats. So put it all on there. Fits in there. Yeah, but it would make more sense just to have two straight sides. I don't know why I didn't do that first, but I hadn't looked at the globe from above and done the experiment, hence the last video. So and that's where I was like, oh right, yeah, it makes more sense. So it fits nicely, all good. Yeah, that's it. So I just thought I'd explain how I did this. So what we have here is 511 million kilometers squared. How can we use that in navigation? Well, what you're trying to get out of this is, first of all, how much of the Mercator map is actually missing. And yes, of course, it's exaggerated and it's distorted. Yes, definitely, but it doesn't make it's. What's the purpose of this? The purpose of this is kind of see where anomalies are, time zones, and proving that we're not sphere, we're slimmer, we're prolate. But I would say that a lot of, if our magnetic equator is the actual equator, you would naturally have to add an extra 10 degrees up in the north without moving the Earth. All you do is you line up to the magnetic equator and you pull that whole ring around and pull it down 10 degrees. Oh, you can't just do that. Yeah, but there's so many bits of evidence that I've tried to put on my channel about the Arctic, and many people saying that there was extra lands up there, but birds said there was extra lands, you know, and it's just trying to get the shape sorted out, and the shape and the orientation, are we inside or out, magnetically aligned, then the magnetics of the structure aren't going to change, but the magnetics in a structure, then those themselves are between the center and the exterior, or you know, the solid earth or the hollow earth, as in we're inside. But I'm doing some work on yeah, maybe I can, let's yeah, just checking there's no yeah, found this. It's called Planet Tracker. Really cool. Set your orientation. It'll tell you